Is day 4 in geometry. It is Monday, June 2nd. Wow. I have never taught June before, so this is new for me. Also, I just can't believe it's already June. That's insane. It's just flying by. So, let's look at the two things I had set up here for you. I put a little handout up here about parallel lines, just as a quick little review. So you can keep this for your notes, unless, of course, you may already have it written down and maybe you don't want extra papers. But just a quick run through of this. When we have two parallel lines and a transversal, that's a third line going through both lines, 8 angles get formed. And every single time, no matter what angle this transversal goes through the parallel lines, these 8 angles will always be related in the same way. 1 and 2, the angles right beside each other, will always add up to 180 degrees. We could say the same thing for these beside each other. 2 and 3, they're on a straight line. They will add up to 180 degrees. 3 and 4 add up. 4 and 1 add up. You can also say that any angles right across from each other are equal to each other. So feel free to use this as a little cheat sheet to help you. Maybe in the future when we get to more complex looking things, you'll be able to say, well, where are they? Let's look at this little paper and it can kind of help you. And I just put underneath here, the vertical angles are equal. That's the ones right across from each other. And I gave you a new word down here. You're not going to have to memorize it, but it does exist. This says adjacent angles. That just means that they're angles right next to each other. And then I wrote the pronunciation, adjacent. So that would be ones that are side by side like that. But yeah, so this is that handout. And now let's go to the do now. So for your do now, I gave you the measure of one angle. Angle B, it's 72 degrees. Now, what I didn't remember to do is tell you that these are parallel lines, but I think you all probably assumed that. So we have the measure of angle B at 72 degrees, and I wanted you to solve for all other missing angles. Now, this looks like a lot of angles to solve for. But I bet it surprised some of you, or maybe it didn't. Maybe you knew immediately. Once you solve for another one, you basically have all the answers. So let's do that. Before we set up any equations, what angles do we already know? 72. We know 72 for B. What other letters do we know, Erica?
You know, the flat line is 180.
I know this flat line here adds up to 180 degrees. Okay, how can that help us?
B and F should be 72 too.
Which one? Say it again.
F.
F. Ooh, what kind of angles are B and F? Do you remember that word starting with a C? Corresponding angles. So we have two groups of 4 here. There's 4 angles here, 4 angles below. B is in the upper right position. F is in the upper right position. These are corresponding. So I can go down here and say that I know angle F is 72 degrees. What else do we know?
D and H are also 72.
How do we know D and H are also 72?
Because they're vertical.
Yes, they're vertical angles. So B is right across from D. They're vertical, so they're equal. So let's write that. D is 72 degrees and H is 72 degrees. I also gave you guys a little hint in the way that I marked these angles. If there's one arc, those little kind of partial circles on the angles, if there's one arc on the angle, they're equal to each other. The two arcs are equal to all angles with two arcs. See that? So that's another way that we show what angles are equal in geometry.
So, should you subtract 72 from 180 and you'll get the angle of A?
You will. Now, what equation would I write though? Does anybody know? How could I solve for angle A using an equation? Erica?
You could write it two ways. You could do 80 minus 72 equals A. Or you could do 72 plus A equals 180.
Yes. Okay, so there's a couple ways. If you can already see this relationship, I know that all of this is 180 degrees. So if I subtract 72, or see that if I like get rid of it, that's all that subtracting is, I'll have A.
It went over.
I could also say, well, A plus B is 180. I don't know what A is. I know B is 72, and I know they add up to 180. They're equal to 180. So these are sort of the two equations that I could write. A plus 72 equals 180, or 180 minus 72 equals A. So let's see, if I wanted to solve this, what would I do?
108 plus 72 equals 180.
Subtract 72 from both ends.
So not plus, yes, subtract 72. Subtract 72 from both sides. And that gives you A equals,
108.
what is it?
108.
108? Beautiful. And over here, if I did 180 minus 72, it's the exact same thing we did here, just written differently. We get 108 equals A.
Would it be negative on your?
Would it be negative what?
You know, the
Negative.
positive number is 180.
Negative 108. How did you get negative? Oh, you did 72 minus 180. We're doing 180 minus 72.
Oh.
Yes, that's okay. And something that you can remember as a rule, you will not get a negative angle. You will not. So if you get a negative answer, I would change it positive. Okay, so if angle A is 108 degrees, what else do we know?
Let's see.
A,
I heard Lisa, C is also 108. Those are right across from each other. I'm going to fill that in.
E and G too.
And then E and G. Also, C and G are corresponding. A and E are corresponding. You guys starting to see the pattern that happens here? Yes, they all just kind of mirror each other, and we get this nice pattern. Every other angle is either equal to each other, you're okay, or they add up to 180. And we can even see it as we list these out. 108, 72, 108, 72, 108, 72, 108, 72. Whenever you make these parallel lines with a transversal going through it, you're only going to come up with two angle measures always. Actually, there's one exception. I'm going to show you the exception. Here's the one exception. If I have a transversal going straight up and down, and I have parallel lines, sorry, it's not super neat. And I tell you that one angle is 90 degrees. What are all the other angles?
Same.
The same. They will all be 90 degrees. That's the only exception. These will all be 90. Because I can look at this and say, well, this is vertical. It is 90 also. Well, and 90 and 90 make 180. So that's also 90. And that's also 90. And then that's corresponding, and that's 90. Oh my goodness, vertical 90. You would fill it out, it's all the same. That makes sense? Okay. Did this help understand the relationships a little bit better? And seeing when you should add to 180, when you should set them equal? Maybe having this chart will help too. Keep this handy. And I will let you know that whenever we move on to the quiz, I'm going to show you on the practice quiz already. You're only going to have 2 questions like this on your quiz. You're going to have one where they're equal, one where you add them up. That's it. Okay. Everything else will be the other stuff, and we'll get to that. Okay, can I teach you something new? No. Does anybody still need to see this? You guys can handle it. I know it. All right, let me pause this and I'm gonna pass something out. I'm gonna go ahead and title my paper and write some notes. Geometry. I just realized while I was making your quiz on Friday, I haven't been titling what unit we're in. If you are wanting to be able to put what unit goes with what, everything we've done up until now is unit 1. But I'm just gonna go ahead and write that on here. So if you wanted that to be on your other notes, unit 1. And it is day 4, so we're gonna write day 4 notes. So we are going to learn how to find the distance between pairs of points on a graph. Now, if we had lines that were straight up and down, we could find the distance very easily because we could just count the boxes. So on your worksheet here on number 1, let's start by drawing a line straight down from one of the points. And let's say there was a point here. What would the distance be between these 2 points? 9? How'd you get that?
Turn it up, I count it out. I count each box.
Just counted the boxes. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. So the distance there would be 9 units. Okay, that's not too hard. Let's see, we could also find the distance between these points here, and that's 5. 1, 2, 3, 4, 5. Yep, that is absolutely correct. Okay. But how would I find the distance between these 2 points?
That's the angle, right?
It does kind of create an angle. It creates 2 different angles, but we're actually not going to use angles to help us figure this out this time.
This point.
We do have points. I want to know the distance between these 2 points. Basically, the distance or the length of this line.
Don't you add 9 and 5?
Add 9 and 5? Well, let's see. If I added 9,
No, that's not
it's going to be a little too big.
It's like a fraction.
A fraction. It could be a fraction. You want me to just tell you?
Lady part with.
There's a special way that we can do this. Now, there's a long formula, and I can write that for you. But I want to teach you the cheat code for solving distance, especially when it's on a graph. So let me ask you guys this. What shape is that? A triangle. We just made a triangle here. And when it comes to triangles, we actually have a special way for solving this length. on a triangle. If we have the other two lengths, we have special formula. And I'm gonna write that down on these notes.
Flip that thing.
Hmm?
Can we flip it? Flip like the triangle. Is it?
Oh, so that it makes like a rectangle?
Yeah.
Ooh, that's a really good idea. We probably could do that, but then we still have the issue of now we have all four side lengths, but how do we go from that
Yeah.
diagonal?
Yeah.
You know, it's kind of tricky. So I want to write a big word up here. And you're not gonna need to know this word until unit 2, but I'm just gonna at least give it to you. It's called Pythagorean.
Theory.
Pythagorean. Wow, that's a big word. Theorem.
What?
What on earth? Theorem. Pythagorean. Pythagorean. Wow. You're gonna sound real smart saying that. Pythagorean. Pythagorean theorem. Pythagorean, I believe, is the last name of some mathematician who came up with this formula. And we can thank him for it because it solves the issue that we have of finding a vertical length and not having units to count that length. So Pythagorean, I think his last name was Pythagoreus. And so this is like Pythagorean theorem. I don't know.
That's a cool name.
I know, right? Like we need to bring some cool names back. But here's his theorem. The theorem is that whenever I have, I'm going to draw a triangle. When I have a triangle and the corner of this triangle creates a 90-degree angle, this has to be 90 degrees. It only works for angles or triangles that have a 90-degree angle in it, which luckily this one does. See that? The box is right there. This is 90 degrees, so we can use it. The Pythagorean theorem says that we label these sides as A, B, and C. It doesn't matter which one is A or B, but C has to be the diagonal one. Has to be. C cannot change. So I'm going to just make sure that I don't lose. C is always the longest side. Yes.
I was just gonna say it's probably better to say the longest side because it might
Yes.
not always.
You're smart. You're smart. C is the longest side. So let me write that. The longest side. So this is a sneak peek into Unit 2 because Unit 2 is just all about triangles. So this will make Unit 2 even easier. So this is the longest side. And with these labels, here's the formula or the theorem. We can say that A squared plus B squared equals C squared. Okay. And what does that mean? Here's what that means. If I have, for example, on number 1 on this worksheet, I have my A and my B, right? So let's label them as that. It doesn't matter if 5 or 9 is A or B. I'm going to make my 9 A. I'll make 5 B. Again, it's okay. It's not exactly the same. So C is my longest side here that I'm solving for. Okay. So we'll go back to the notes and we'll use these numbers. And I'm gonna show you how we do this. So I said that A is 9. B is 5. D, we're gonna solve for. So now that we have a formula, we want to put these numbers, plug them in to the letters that we've given them. So instead of A squared, we're gonna write 9 squared. Good. 9 squared plus B is 5, so 5 squared. And that equals, we're going to solve for C squared. So step 1, we're plugging in the numbers. Now for step 2, we need to square anything that needs to be squared. Now, quick review from algebra and beyond. What does it mean to square something?
Take 9 times 9.
Yes. So 9 times 9,
81.
that's 81.
5 times 5.
Yes, and then 5 times 5 is 25. So we've done that. We've plugged our numbers in. We've squared the numbers. I'm just going to bring down C squared. We don't know C yet. Now, do I have any like terms to combine? I do.
81 plus 25.
81 plus 25. What is that?
106.
106?
Yeah.
Okay, so I have 106 equals C squared. Now, does anybody have an idea what I would do at this point?
106 times 106.
106 times 106. Ooh. Now, that's a great idea. The only problem is we don't have 106 squared, we have C squared.
We should do that.
We can't divide.
We don't have a number.
Yeah, we don't have a number. So here's what we're gonna do. This is what I didn't teach you last term. Whenever we are solving an equation, we're always doing the opposite. We're using inverse operations. You know, if it was multiplication, we could solve by dividing. If it was addition, we'd solve by subtracting. Now we have a squared. Do you know what the opposite of something squared is? I tell you. The opposite of x squared, yes, is the square root of x. Woo! Okay, so what we're going to do to get the square root of c squared, that's going to get rid of that squared and make it c all by itself. We need to find the square root of both sides. So remember, a square root just means that I'm asking what can I multiply by itself to get this answer? Well, c times c is c squared. So the square root of c squared cancels that out, and it's c. Okay, so now I have c. Yes.
Final answer is going to be a decimal between 10 and 11.
Okay, decimal between 10 and 11. So here, let's make sure everybody knows how to find the square root on their calculator. If you have this kind of calculator, here's what we'll do. Make sure it's on, and you are going to first hit the second button
Excuse me.
Let me clear my screen. Second, that's the blue button at the top left. And then find next to 7, the x squared. And right above it, there's a square root symbol in blue. You're going to click that, and it pops up on your screen. You see that? There's your square root. And we just type in 106. And we get 10.2956301. And I'm sure it goes on and on.
Yeah, so it'd be 10.29.
We can either go with, 2 decimal places. If we did 10.29, oh my
It'd just
goodness.
be 10.30.
Yes, it would be. Okay, here's the second square root 106. Oh my gosh. There we go. Okay, so I'm not going to be real picky about your decimals. You can say 10.2, 10.3, 10.29, 10.30. As long as it is in the ballpark, it's similar to the correct answer, I will take it. So I'm just going to write 10.30. 10.30. And that is our answer for C. And that's the distance formula. That's it. It's plugging in our numbers, we find those side lengths, and then we solve for the missing one. So we square the numbers, and then I'm going to write for my third step, square root both sides. So number 1, our answer is 10.30, or whatever decimal you decide to keep it as. All right, C equals 10. Because it doesn't specify units, it's fine if you just write the number. You don't have to put units. So that's what I put for number 1, 10.30. Okay, so let's look at number 2. And I'm probably going to solve most of these out on a piece of paper just because there's not a ton of space. So that was number 1. Let's do number 2. I'm going to pull my worksheet up again. So for number 2, I'm trying to do the same thing. I want to find this diagonal distance. I can't. It's 5 and 1. Okay, so let's see. What are our side lengths? We have 1, 2, 3, 4, 5. Yes. And then that's just one unit. 5 and 1. So I'm gonna pull this to the side, and I'm gonna write my values here. So I have a, bless you.
Thank you.
I'm gonna just do 5, 1. And remember, we're using the formula or the theorem, a squared plus b squared equals c squared. So how should I begin?
5 squared plus 1 squared.
It's 5 squared plus 1 squared equals c squared.
25.
Yes, 5 squared is 25. 1 squared is just 1. And that's still equal to c squared.
26.
26 equals c squared. And we just have one more step, don't we?
Square root.
Square root. Square root of both sides. That's going to give you c all by itself. 5.1?
Yeah.
Okay, let's see, second square root. Oops, my goodness, I can't use a calculator to save my life. Second square root, 26. Yeah, 5.1. Or you could put 5.099, whatever works. I'm gonna put 5.1 or 5.10. 5.1 is C. So that's our answer for number 2. Yeah, it's not too bad. It looks a little scary, but it's not too bad. I think it's also, it just looks scary to be seeing a symbol we're not used to using, that square
Can you
root.
slow down just a little bit for me?
Absolutely, absolutely.
I appreciate you.
Yes. Okay, so let's do the next one real nice and slow. Make sure that everybody's following at the same speed. I don't want us to get too fast. So let me write that answer down. It's 5.1. Let me give everybody a minute to write down number 2. And then for number 3, let's go really slow, step by step. And I'm going to have you raise your hands for the next one to answer things. That way we give everybody enough time to get it all written down. Now, before we go to number 3, do we have any questions about what we just did in 1 and 2? At any point, if you come up with questions, interrupt me, ask them. Ready for number 3? All right. So number 3, very slowly, let's just say we are starting with this. This is all we got. We've got this graph here. Somebody, by raising your hand, tell me, how would I begin figuring out where to start here? Titanium.
You can count your blocks.
Count my blocks. What do you mean count my
From your
blocks?
points.
Oh,
points.
from my point.
Yes.
Okay. In what direction? Like, am I going to count from this point over?
Going down.
Going down. Okay. So I'm going to count all of these spaces and see what that length is. So let's see. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I have 8 for one side. Perfect. And what would I do next? You want to tell me that too?
Yeah, go from the point you just left and you go over to the other point. So you have to leave it in.
Oh, okay. So basically, we're taking that diagonal line and we're going from one point straight down, from one point straight over, and the goal is to get a triangle. We want to draw a triangle. So here we have a triangle with 2 sides that are measured either 8 or 2 units. So let's now that we have this, I'm going to move over to my note page. Can I move this? Okay. And let's remember what's really happening here. When I have my triangle and my straight up and down, I've got an A and a B. C is going to be that diagonal longest side. So does it matter which one is A and which one's B though? It doesn't really matter as long as I don't make one of those C. So we're going to use 8 and 2, the lengths that we just measured. I'll use 8 for A, and I'll use 2 for B. And we need to solve for C. If you feel like you've got this, you are more than welcome to work ahead, and that is Wonderful. Okay. Just want to make sure everybody's got it before we start trucking along. So now I've got my side lengths figured out, except for C. Does anybody know where would I go from here?
Square them.
Square them. Okay. Now, before we square them, what should I be writing? Yes, Kiana.
Plug your number in.
Yes.
Then
Let's.
you have 8 square
Mhm.
plus 2 square equals 6 square.
Perfect. Okay. Now, before I move on and start solving this, does anyone not feel sure how I went from the 8 and the 2 to 8 squared plus 2 squared equals C squared? Anybody not feel sure how we got to here? Just as a quick reminder, this is how we did it. A squared plus B squared equals C squared. That will never change. That's just the formula, the theorem. And I just replaced 8 with A, B with 2, and I don't know C yet. Okay, so now that it's all plugged in, Titania, we're going to do your step. We're going to square these numbers. What is 8 times 8? 64. And I'll bring down my plus sign. 2 times 2 is 4. Bring down my equals. Bring down C squared. Yes, then we'll just add these together. 64 plus 4 is 68. And this very last step that I see people forget a lot, but we're not going to forget. We're going to remember what is the last thing I do always. Square root. We're going to find the square root of C squared, which gives us C all by itself. And then we need to type in the square root of 68. You said 8.2? Okay, let's see. Make sure I can do it. And guys, calculator skills is another part of this class that, we're going to have to know how to type these in. So if you get to this point and you're ever forgetting how to type in the square root, let me know. I can tell you again. So second, square root 68, and I got, same thing, 8.2.
8.25 work.
8.25 would absolutely work. It's actually even more accurate. Okay, so I'm actually gonna write 8.25. I always say I like 2 decimal places. But again, I'm not grading you on that, so it's really up to you. So for number 3 on our worksheet, 8.25 is the distance. And you'll see as we do more of these, the C value that we're solving for is always going to be bigger than the other 2 lengths. Always, always. Even if it's just a little bit. Like on number 2, 5 and 1. C is technically still bigger. 5.1 isn't much bigger, but it's bigger. Okay. Just like on this one, we had 8 and 2. Now my side length C was right that 8.25. Too bad. Okay. We've gone through 3 together. Does anybody want us to go through another one before I let you try some on your own? One more? Yeah. Okay, one more. Let's see. Are there any that stand out that you would like me to run through over others? I mean, number 4 looks a little tricky, but number 6? Yeah, let's look at number 6. Okay, number 6. Yes. Try to fit my work on this paper. Maybe I'll just use a pencil. Okay, first step. What should I do? Yeah, let's count the squares. I'm trying to make a triangle. Now just make sure that you're counting from the points and you're not just, I don't know, like I saw this and this line was going through the 4 and I almost started drawing my line here and that would have been wrong. Make sure that it starts all the way from the end points of that line. So here's my triangle. And I need to count the spaces. How many spaces are here? 3. And here, 7. 7. 1, 2, 3, 4, 5, 6, 7. Perfect. Okay, so 7 and 3.
Could you do it the other way? I did it the other way.
The other way.
I made a triangle on top.
Oh, like this?
Yeah.
Yes. Oh, that is a great question. So guess what? If you do it on top or on bottom, you're going to get the same numbers. This is still 3. This is still 7. You could do that with all the other ones too, actually. So if I look back at like number 3, this is still 8. This is still 2. This is still 9. This is still 5. You can do it on top or on bottom. It'll always work. That's a good question, though. Okay, so I've got my numbers. Where do the numbers go?
And equal 3.
Sure, we could say A is 3. B is 7. You could also say A is 7 and B is 3. You're going to get the same answer. Okay, so let's see. If A is 3, 3 squared instead of the A plus B squared. What's B?
7.
7. Perfect. Equals C squared. So 3 squared, 9. That's 3 times 3.
Plus 49.
Plus, yes, 7 times 7 gives us 49. Equals C squared.
We got 58.
58. Yeah, 58 is when 9 and 49 take together.
Equals C squared.
Equals C squared.
You should get 7.61.
Ooh, yeah. Now, how'd you get 7.61? What'd you do?
Square root.
Square root. Good. Good, good, good. So we're going to square root both sides. And that gives us C by itself. And second square root 58. We do get 7.615773. 7.62 is what I'm gonna put. Round that up.
Do you have to round it up?
You do not have to round up. You might in the future if you decide to go to like college after this, but you know, as long as you know how to use these formulas, I'm happy with that. So 7.62 is what I'll put. If you had 7.6 or 7.61, I would count it right. I'm not gonna be that picky. It's not bad, right? It's not too bad. It's just once you gotta learn the process, and once you got the process, it's not too bad.
Is number 7 a trick question?
Number 7 is a trick question. What's it mean? Wow. Yep, that is very fine. Well, technically, you're gonna find an answer. It's just gonna be a really interesting one. All right. Okay. You guys want to try some on your own?
Yeah.
Yes? No? Maybe?
We should do 7 because 7 is looking.
Do you want to do 7?
Do 7.
It's not that bad.
It's not.
It's really good.
It's not too bad. I don't know. I think, how about this?
7 is easy. You just
How about this? We've done 4 of these together. I'm going to set a timer for about 15 minutes or so. And I want you guys to do as many of these as you can, but I'm not going to say on your own necessarily. I want you to help each other, okay? And I'm here to help. Again, I think it's always going to help you if you're, talking about what you're not understanding so that your classmates can help and so I can help and so you can learn. So here's what I want you to do right now. I want you to work on some of these by yourselves or with your classmates. And after that, we'll look at a few together. So I'll just pause this and I will be around to check on y'all. All right, so back to our worksheet. I'm just gonna give you the answers like I said, and you can check your work, see if you got the same answers that I'm about to give you. And if any of your answers don't match or you're not totally sure, you are welcome to ask me about that. We can go over some. So, number 1 we did together, we got 10.30. Number 2, we got 5.1. Number 3, we got 8.2 or 8.25. Number 4, the answer is 10. Okay. Number 5. Yes.
Yeah.
You got 1004.
10.04 is perfectly fine.
Yeah, okay.
Absolutely. Yes. That is perfectly fine. So I'm looking off of the answer key from this worksheet. So they only did 1 decimal point, which is probably why they took off that 04.
Yeah.
10.04 is actually, I think, a better answer because it's more accurate. Because this is not exactly 10. It's a little bit bigger. Okay, number 5, 9.2. Number 6, we did together, 7.62. And that is the first page, so we'll go to the back. And on the back, number 7, there's that little one. C is 1.4. Yep. Yes. Number 8, 5.4.
Oh, no, that's right. Never mind.
You got it?
I looked at the wrong problem.
That's number 8. Number 9, 12.8. And again, if any of these answers don't match yours, circle the number and you can ask me about it. We can look at it. Number 10, 9.2. Number 11, 2.8.
How do you put 3.0?
3.0, was it? What was the actual decimal that you got?
I got. I just wrote 3.
Okay, so whenever you do that, it's the square root of 8, I believe.
Yeah.
The square root of 8, let me see what that comes out to be when I type it in. Because you only ever want to round up to 3 if it was 2.99. So let's see. Square root of 8 is 2.82. So you could say 2.8, you could say 2.83, but we couldn't say 3.0.
Okay.
Okay. And last but not least, number 12, the answer key says 2.2. Okay. Any questions? How do we feel? We feel okay?
Yeah.
Good. Okay. I would like to let you guys have a little break. And I want you to turn this worksheet in. Okay. Please, before you turn it in, write your name on it. Write your name on it. Turn it in.
Yeah, let me circle my answers first before we do
Perfect. And feel free to take a break. Let's say we'll come back at 10:50. That gives us like 18 minutes, like a little over 15. 10:50, we'll come back. Everybody take a little break. Oh, we're back. And we're going to pull our notes back out. and learn one more thing. Now, I'm gonna rip this out and title my next page. Um, let's see. Oh, good. This is day. Continued. So we've just figured out how to find the distance between 2 points that are diagonally across from each other. And we used the Pythagorean theorem to do that. So now we're going to talk about, let me grab this other worksheet. And I will hand this out to everybody here in a moment. We're going to talk about finding a midpoint. Now, first we need to make sure we know what is a midpoint. So if I had a graph like this, and there were points on it, we would be able to name those points as coordinates. Let me actually just use that last paper so that we can see what's going on. For example, let's say I wanted to name this point. Coordinates can be named with two values. There is an x value and a y value. So we ask ourselves, where does this point line up with the x-axis, the x going left to right? So I'm going to look straight down, and it lines up with -4 on the x-axis. So that would be -4. And then on the y-axis, where does this line up? 3. Perfect. So that's just a quick review. What are coordinates? It's just telling us a place on the graph. Now, we're not going to be using a graph for this next part. We're just going to be given coordinates. So this is just to kind of help us remember what the coordinates are. But moving forward, let's title this midpoint. Say finding the mid. Start with a little bit of a visual representation. For example, if this point and this point were on a line and they're the end points, midpoint would just be right in the middle. Something right here. The point in the middle is where that name midpoint comes from. It's talking about the middle, right in between. So if I were to tell you, let's maybe only look in the x direction. If this point was, let's see, 0, 0, 0, and this was 4, 0. Does anybody know what the midpoint would be?
2, 0.
2, 0. The reason for that is because 2 is right in between 0 and 4. We would have 0, 1, 2, 3, 4. So I can show you that 0, 1, 2, 3, 4. The midpoint would be 2, 0. Now this is great and all whenever we have a simple picture like this, but we're going to look at more complicated numbers where you wouldn't, bless you, where you wouldn't be able to find the midpoint this easily. And I'm going to give you a formula. So here's the formula. I'll give you that first. Midpoint formula. And this is one we'll use quite a bit. So have it highlighted in your notes or somewhere where you know you can come back and find it. But to find the midpoint formula, first of all, our answer is not just going to be a number. Notice how here the midpoint was an x value and a y value. Our midpoint formula is going to give us an x value and a y value as well. So I'm going to start this formula by making a giant coordinate. And here's what we'll do. We have to solve for the x and then solve for the y. We are going to use x1 plus x2 divided by 2. That's going to give us our x value. And the y value is exactly the same except for it's with the letter y. y1 plus y2 divided by 2. This is a midpoint formula. And now we can test this formula using that problem above just to make sure it works. Let's do it. This is the formula that we need. So let's say we wanted to use this to solve this problem I gave you above. Here's how these problems will be written. I'll say example below. You'll see something that'll say find the midpoint for each set of endpoints. So I'll just write that direction. Find the midpoint for each set of endpoints. So here will be our first example. We'll start simple. The set of endpoints I would give you is the 0, 0 and 4, 0. So when we use this formula, the very first thing we would start with, and I'm going to use some colors for this. You may remember from previous classes, anytime I am doing colors with X's and Y's, I use red for X, blue for Y, and I'm going to try to keep that pretty consistent. But the very first step that we want to take is we're going to label our X values and our Y values. So what are my X values? Yep, that first 0 is an X, and that 4 is an X. And we'll call the 0 x1, and the 4 will be x2, because this is our first coordinate, this is our second coordinate. So the next 0 will be y1, and the 0 with the 4 will be y2. So I'm gonna write over to the side. If you are somebody that likes to have kind of a step-by-step guide, I'm gonna say step 1, label the coordinates. And it will always be x1, y1, x2, y2. Step 1. So we have that. Now the next step is we're just gonna plug these in to the midpoint formula. So let's see. 2 plug x and y values into the formula. So we have everything labeled. Now what I'm going to do is I'm going to start with just my x's. I'm going to just do one value at a time, but I am going to go ahead and give myself a big parenthesis. And I'm going to put a plus sign here because I'm going to do something plus something, always divided by 2. Okay, so my formula says we're going to do x1 plus x2. So what am I going to write here?
0 plus 4.
0 is x1, 4 is x2. Perfect. So I have 0 plus 4 divided by 2. So that will be my first coordinate. And for the y values, it's the same thing. We need to add, yes, the numbers together, divide by 2. And we're using y's. y1 is 0, y2 is 0. Now, it looks like a lot of numbers jumbled up, but remember, we're just doing one thing at a time. One thing at a time. So step 3, once you've plugged everything in, is we're just going to simplify using our order of operations. Now remember, even though in the order of operations, division comes before addition and subtraction, because this is a fraction, we assume there's parentheses here. We do the addition on top first, and then we can divide by 2. So simplify everything. Simplify everything. Okay, so we're in the third step. I'm going to go from each value. What is 0 plus 4?
4.
4. And I'll bring down that divided by 2.
0.
And then, yep,
Plus 0.
over here we have 0 plus 0 is just 0. Divided by 2. Now, if you are somebody that thinks doing both of these at the same time will confuse you or get you out of order and mixed up, just do all the steps to simplify x and then move on to the y. You can do this in many different orders. Okay, so let's go back to x's. What's 4 divided by 2? 2. So that's our x value. And what's 0 divided by 2? 0. And that is our answer. What we got there? Not too bad. So if you'll notice, the picture we drew at the top of these notes, the midpoint we said was 2, 0, and looky here, we found the same thing with the formula. So it works. It works. So I'll leave this up for a second since I did write a lot of things, so you guys can get caught up and write this in your notes. And while I leave this up, I'm going to pass out that worksheet with the midpoint formula problems on it. And we'll do some of these. All right, everybody should have this worksheet now. That says midpoint formula. Yes.
Just like, no, if it's okay if I write it the way I did.
Sure, let me see how you wrote it. All right, so let's look at number 1, and I'm going to do my work on a separate sheet. Actually, I think I can fit it on here. This is a little more space. Do that. Move this side. Okay, so number 1, I'm finding the midpoint between these coordinates 3, 2 and -14, 13. What's the very first step I should do?
Label your coordinates.
Label your coordinates. Good. So I've got x1, x2. I've got y1, y2. Coordinates labeled. Done.
So
Okay.
now we put 3 and -14 on one side and x and 2 and 13 on the other side.
Perfect. So we need to now plug these in. Dividing by 2 and I'm adding. So I've got 3 plus -14 for my x's. I'm dividing that by 2. And for my y's, 2 and 13 by 2. Okay, all plugged in. So let's look at the x values here. 3 plus -14, what is that? Say it again.
8 to 10.
Almost.
-17.
Almost. -11. -11.
Subtracting.
If it was -3 minus 14, then yes, that would be right.
Oh, 9 part.
Yes, -11 is what we get with that. So -11 divided by 2,
-5.
-5.5. Good. Perfect. Okay, and now let's look at our y's. What's 2 plus 13?
15.
15. Divide by 2, what is that?
7.5.
7.5.
That's pretty good.
And that's your answer.
Yeah.
There you go. Not too bad. It's just like 3 quick little steps. Okay, so I'll leave that up for just a second. I'm going to zoom out. We'll look at number 2. Okay, so number 2, we want to label our coordinates. x1, x2. Y2. Okay. And I want to plug those in. So I'll start with my x's. -9 plus 14 are my x values. Now, with addition, addition has a special property of where you can actually switch the numbers around and it doesn't make a difference. Like 2 plus 3 is 5. 3 plus 2 is 5. So I could do negative 9 plus 14. I could also do 14 plus negative 9, which is 14 minus 9. So if you like switch the numbers around, if it makes it easier for you, you can do that. I'll write it the way it is so nobody's like, what are you doing? Negative 9 plus 14.
Will it always be plus?
Yes, with this formula, it will always be plus. We add them and then just divide by 2. Okay, and then our y,
10 plus 4.
perfect, 10 plus 4 divided by 2.
So will it always be divided by 2?
Always, yes.
After you add though.
And the reason we're dividing by 2 is because what's really happening is we're finding the average of the x values, and then we're finding the average of the y values. So like if you want to find the average of something, you add it together and divide it by however many items you added together. So we're adding 2 things together, we divide by 2. And that will never change for this formula. So what is negative 9 plus 14? 5. Okay, 5. Divide by 2, and what does that give you? 2.5. Perfect. And 10 plus 4 is 14. Divide by 2, what's that?
5.
7.
Duh, put the wrong number in there.
That's
My
okay.
fault.
That's all right. 14 divided by 2 is 7. And that's your answer, 2.5 comma 7. Now, do not forget your parentheses and the comma separating them. Remember, our answer is a coordinate. Our answer is a point. If it's not in parentheses and doesn't have a comma between it, your answer's not going to be correct. You'll have the right numbers, but you lose some points for not putting it in the right format. Okay. Do we want to go through any more together? Or y'all want to try some of these by yourself? How about I ask this? Does anyone in here want to see one more example? Anybody? Anybody? One more. Okay, let's do one more just in case. Let's see if there's any that look tricky. How about we look at, I don't know, I'm gonna like number 5 maybe. That one's got a bunch of negatives in it. Okay, let's try number 5 together. This will be the last one I do with you, and then I'm gonna let you try some by yourself. Okay, so I'm labeling my x's, x1, x2. And then I'm gonna label my y's, y1, y2. Okay, what should I do now? Put them together. So we'll look at the x's first. What numbers am I gonna add together?
Negative 7.
Uh-huh. Negative 7 plus negative 12. So I'm gonna put that there. And remember that in the formula we are dividing by 2. Okay, and do the y values next. What numbers do I add together for the y's? Negative 13 plus 1. And again, we're always dividing by 2. Now, when you're adding together 2 negative numbers, you can just add them like normal positive numbers. Your answer is just going to be negative. So what's 7 plus 12?
19.
It's 19. But since they're both negative,
Negative.
negative 19. Good. Divide by 2. What's negative 19 divided by 2?
9.5. Negative 9.5.
Negative 9.5. There's my x value. Now let's look at the y's. Negative 13 plus 1.
-12.
Negative 12. Divide that by 2.
-6.
Negative 6. Perfect. And that's our answer, negative 9.5, negative 6. Okay. So guys, that is the second thing that I said I was going to teach you today. I want you to do some practice on this worksheet now. So I'm going to set a timer and I will come around the room, see if any of you would like any one-on-one help. So feel free to work together, help each other out. You guys are doing really good. So let me pause this and I'll set a little timer. Okay, so number 1 we did together. We got negative 5.5 for our x, 7.5 for our y. Number 2 we did together as well, 2.5 for the x and 7 for the y. Number 3, x value is negative 3, y value 5.5. Number 4, x value is positive 3.5 and the y value negative 1.5. Number 5 we did together. Our x value was negative 9.5, y was negative 6. Number 6, x value is 3, y value is negative 12. Number 7, x value is 3, y value is 0. Number 8, the x value is 1.5, the y value is negative 3.5. Okay, before I go to the back side, everybody got these, or do we need to look up at any previous ones? Yes.
When I did it myself, I got a small error on number 2, but it was just, I did the math wrong.
Gotcha. Well, good catch anyway. We learned through mistakes. Okay, I'm gonna flip to the back side.
Yeah, I messed up. Yeah, you're right.
Number 9, the x value is 3. The y value is negative 7. Number 10, the x value is 3. The y value is negative 4. Number 11, the x value is negative 4. The y value is 12.5. Number 12, the x value is 5.5. The y value is 3.5. Number 13, the x is 0.5. The y value should be 4.5. Number 14, the x value is negative 1. The y value is positive 1.5. Okay. Number 15, the x value, negative 7.5. And the y value is 1. Okay, and last but not least, number 16, the x value is negative 1.5. And the y is 8. Okay, so that is the answers for this worksheet. Make sure you have it worked out on the front side. Yes. Anybody got questions about that? Turn this in.
I want to make sure I did I made a correction.
You are right.
Y'all know I can
Okay.
choose.
What you do?
Yeah, always count one under the dot. So now I gotta change my answer back.
Who knows? It could have just been a silly mistake.
First time
Like
before.
sometimes I'm thinking the right number and my hand just doesn't move my brain. It could have just been that. But you clearly know how to do it.
I'm trying to figure out.
Four square plus three square.
Who knows? Looks great though. Looks great. Okay, I am just gonna say this again for the video. This is your exit ticket, day 4. This is due on Friday. For the first question, you're gonna find the distance between the 2 points on the graph. And number 2, you're gonna find the midpoint for the set of endpoints. And that is all. Make sure you turn this in. Make sure you turn the midpoint formula worksheet in and the distance formula. And that's it. I'm going to end the recording there. When you're done with that, you're free to go.